Our speaker this evening has previously held the roles of Chief Operating Officer of Monty Program, as well as has held a previous role at Microsoft working on SQL Server. Please welcome the VP of Engineering for MariaDB, Rasmus Johansson.
Thank you. Thank you, Eric. So I guess you didn't draw the backpack yet.
Oh, at the end of the day.
Okay,
Yeah,
thank you.
Pass the roll around while you're talking.
All right, thank you. So now after you know everything about MariaDB, I'm going to go through the boring stuff. No, sorry, I'm trying to make it a little bit fun. I'm going to demo things, and I'm going to talk about what new we have here. How many uses MariaDB or have tried it? So not that many. So I shouldn't, I guess, go too deep then. And please ask and scream and shout if you have any questions. There will, of course, also be time in the end to ask questions, and I'll be here. And I do have, or we have a team here present, and I will want to present a couple of the persons that are here. So we have Bob, who is responsible for the area of New York and some bigger area in terms of sales, and John, who is a solutions architect. So if you are thinking about doing something, then these two guys can definitely help you out. So let's dive into what we have been up to lately. You already got a little bit of the history of MariaDB, where we are headquartered and so on. We're about 150 persons now in MariaDB, so we have come a bit on the way, so to say. Are we a startup anymore? That's a question we get quite often nowadays. And if you really look at how to categorize us, I think we fall into the growth companies. So I'll start off with telling about MariaDB TX 3.0, which is our latest release. It actually includes a few products inside it, of which one is my area of expertise, and that's also the area of engineering where I focus, and that's the server itself. So I will go quite much more through that than the other products. So if we look at what does the MariaDB TX 3.0 consist of, of course you need more than the database server itself to create a solution. So you will need connectors, obviously, so that your application can connect to the server itself. But then you need quite a lot more, especially if your application or data grows big. So we do have something called a proxy server, which helps when your data doesn't fit on one server anymore, and you need to either start sharding, load balancing, and so on. And we do have a cluster product also when you need high availability for MariaDB. And of course, normal tools around a database are included as well, so that you can manage it, you can monitor it, back it up, and so on. So what's really new in MariaDB TX 3.0? And this is now taking a look at it from a server perspective. So how MariaDB is built, someone said InnoDB, someone said Spider, someone said MyRocks already today. Those are all examples of storage engines inside MariaDB, and all of them have a different purpose. They are meant for different sort of workloads. A normal relational database, can you really define what that workload is? We call it mixed. You have both. You can, or usually you have reads and writes, a variety of them, and it changes how big they are and so on. Then if you need more writes than a normal relational database can handle, then you might need something that falls into a wide column database area. Then there exists document databases out there, and there exist columnar databases, analytical ones, of which already MariaDB TX was mentioned. So it's all about storing the data in the right way so that it's efficient for the application to show it to the users or write it to disk. There are different characteristics on the storage engines. So InnoDB was mentioned also today. That's a long time storage engine which has been around and originally was developed by MySQL, or before that even by a separate company that MySQL bought, or under Oracle. And they use the B3 to structure the data for good performance in querying the data. But then if you have more write intensity, then there are other interesting alternatives out there. And many of them make use of the LSM tree. I won't dive very much into what these actually mean. But if you want to know really or more details about them, you can talk to me, and we can even connect you with the developers that can go even deeper. The spider was mentioned. That's an example of distributed, and then we have columnar data as well. So the idea is that you would have one common top level, which would be MariaDB, and then you have different storage engines below it, depending on your needs. So then we come to the products themselves. So it looks like this: InnoDB, MyRocks, Spider, column store. And I think I mentioned the most important differences already. So MyRocks, which was developed together with Facebook, that's really when you have a lot of writes in your application. And I would say that you have a lot of writes and your data size is so big that you can't place it in memory anymore. Then you might need to look at something like MyRocks. InnoDB, the traditional OLTP transactional storage engine. Spider, I'll dive deeper into that later because that's a new thing. It's now GA and a stable product in TX 3.0. And AX, I believe you had already a talk. Have you heard about AX before? I think we had a presentation on AX a year ago or something. Maybe not. So a little bit about MyRocks to start with. How did that come along? So Google had something below their solutions that was called Bigtable. And there are two main directions from Bigtable. One was also developed further by Google, which was LevelDB. At some point, I don't know if it's true anymore, but the Chrome browser included an embedded LevelDB. And then the HBase, which is under Apache nowadays. Then Facebook turned LevelDB into RocksDB to fit it for their needs. So you can imagine, if you think about Facebook, about the masses of data that they need to store, and with what kinds of amounts of writes they are dealing with. So the RocksDB is really made for that. And then out of RocksDB, which is really a key value store, on top of that, Facebook, and we helped build MyRocks, which is now then RocksDB with the SQL layer on top of it. So a little bit more about MyRocks, then I'll leave that part for you to test out. So it's really optimized for SSDs and for enormous data volumes. So when you have, this is a benchmark done when you actually have things in memory. Now the blue pillars there are InnoDB. So you'll see that when you have a lot of memory and you can fit most of your data in memory, InnoDB will be significant faster still. But what if your data is so big that you can't cache it anymore? Then it looks like this. The green ones are MyRocks. And I guess this really comes down to that you test out MyRocks and InnoDB on your systems, and then make a choice which one to use for what purpose. Then about Spider. So the name is actually visualizing what it does. It's for scalability. When one server is not enough, one table doesn't fit on one server, you need more speed in one table, you need several servers maybe to take care of processing the data in your table, and so on. So this is really focusing on that. You can partition a table over several servers, like here. So you split it, in this example, over 2, 3. And then you can have another set of this setup so that you get high availability also. So the idea here is that you have the Spider on top, the Spider tables. They connect to InnoDB tables that are either on the same or then on separate servers. Typically on separate, because what you want is more processing power and scalability. You want to shard out. So it could look like this, for example, in the end, that you are creating an application where you make use of microservices. You use order services, history services, and analytical services. And you realize that, hey, I need, for the order service to work, I need something that can take a lot of write load. And you use MyRocks there. Then you have a history service where it's more reads than write, and you take InnoDB for that. And then you have a huge history of data that you analyze, and there you make use of column store. Okay, so let's jump to something different. So that was all about choosing the right storage engine for your needs and your workloads. Let me do a short warm-up to the demo here. So I'm going to, I wonder why it's not showing my screen now. Let's see if I get it this easily. Okay. So I'm going to do a couple of demos, and to be able to do that, I have to set up MariaDB in Docker. Is everyone familiar with Docker? Yeah. So it makes it quite easy to separate kind of the installation from the rest of what I have running here on my laptop. And as you can see now, if you're familiar with Docker, it's pretty empty. There is no image in there. So what I do then is that I will, sorry. I'll just list what I have here. This is not connected to internet now, so I don't need to pull down anything, download anything. So I have two images that are locally stored here on my computer. That's 10.2 of MariaDB and the latest version, which is 10.3, which is included in TX 3.0. So I'll use the latest version to show what I want now. I had the run command here. So what I'll do is that I'll tell Docker that I want to run a container called MariaDB_demo. I want to put the root password to my pass, and I want to expose the port 3306, and I want it to be based on the latest Docker image of MariaDB. And that's what I now did. So now if I do this docker ps again, you'll see that I have the latest version of MariaDB running there. And now if I go over to the MariaDB client, the command prompt client, I should be able to log in. And I had the password mypass, and there we go. So it's fairly easy to set up a development environment in this way. Just pull the latest Docker image from the Docker hub. You don't need to do anything else than install Docker on your computer. After this, we're ready to start working with it. But before we go to that, let's take a look at a few more things in the slides. I'm sorry for the confusion here with the screens. It somehow mirrors once in a while, and sometimes it extends the. So a few new things in MariaDB. We do have, and we have actually had for a while already, row compression. This becomes important, of course, when you have a lot of data. We also have page compression. When things are stored on disk, it's written in pages. But what is new is column compression. So you can define that these and these big columns should actually be compressed in my database. And it's storage engine independent, so you can use it on MyRocks, you can use it on InnoDB, on Spider, and so on. Okay. Then we also introduced something called invisible columns. So you can actually hide columns. I guess you can all think about different use cases when you could make use of something secret in your rows of data. They don't show up in your queries if you do it like this, for example. But if you explicitly ask for them, then they are returned. So you need to know the name of the column to be able to get to the data. Then, of course, I will be talking about data masking and obfuscation and so on. Then you can really make sure that no one sees the data if it's really secret. Oh, then you need to have the rights. The question was, what if you forget the column name? Then you need to have enough rights to show the create statement for the table, because then you will see what the column name is. So adding a column is also something that we have been working on. It's very costly to add a column typically, or has been, because you have to copy the whole data to a new table, which has the new column. And what we have done now is introduced something called instant add column. So where a trick is done so that you will have it almost there immediately. It's like an insert. Of course, there are some caveats that it will be always be the last column, and you can't use it if the row or if the rows are compressed and so on. And an example on how it could look if you make use of both invisible and then add a column and so on. Okay, then to something that I will demo. Does the word temporal say anything to you? What could it be about? Does anyone have a guess?
It's time-based.
Yes, it's time-based, and it's the other word, or the actual standard around this, is called system versioned tables. So what it does is that you define that a table makes use of system versioning. And what it does then is that if you update a row, it will automatically and invisibly make sure that a version of that row is kept in the history. And that's what I'm going to show you now. Let's see if this works. Eric, by the way, this is red, this thing that is supposed to record my screen.
Red solid or red blinking?
Red blinking. Is it good? Okay. All right, so I need to exit the presentation, and if it's blue,
Then you just killed off the slide recorder.
okay, I'll click it again.
Yes, please.
It seems to, when I exit the presentation, it seems to kill that.
Because the resolution is changing.
I guess so, yes. So what I want to start off with is just to create a database. Create database, and I'll call it company. Like that. So one row, and then we need to use that database also. Database changed. Is this a familiar tool to anyone? Okay, good. So this is the MariaDB client, and it's based command prompt based. So let's then move on. So I want to create a table that has versioning on it. So that's identified by the with system versioning on the end there. So I'll copy paste that into here, and it's going to be a table called person. Done. Let's just check that it's there. Yes, we have the table person in the database. Then I'll do just a select to show that it's completely empty, of course. Then I want to insert one row. I'll do a select immediately after so that it... Okay, I'm in the database now, in the table. And this is now the system version table. So now comes the fun part. What happens if I change department a couple of times? First to department 2 and then department 3. Okay, there we go. So now I've updated that row twice. So how many rows should we have there for, if I look at history also? We should of course have 3 rows. So they are all stored there. And I get them visible now by defining that I want for system time all timestamps that there are. I want them visible. And this is how I get them. So here I see them. But this doesn't really tell me when things changed. So I want to include that as well. So I'll ask for row start and row end in addition to all other columns. So now you'll see timestamps there as well. When was that row the valid row for that data? And I can of course request one specific row by defining that I want a row as of is the secret word here to use, and I need to put something that matches what I just did. Since this is system generated time, I need to type in something here that actually, let's see what happens if I do this. Shouldn't I get the middle one then? No, the first. Interesting. Oh, okay. It has to be a little bit bigger, I guess. Let's do this then. Incorrect data. Now then, what's wrong with my? Oh, there I put the colon there. Yes. Okay. All right. I didn't get the time completely right, but it gave me the last row. Then I can, of course, also delete the data. So then I would do this. Delete history from the table name, and then I define when, and I'm gonna put after here. So let's see what happens then. I guess oh. Let's see if okay, I have something wrong in my timestamp there, but the idea is that of course that you delete the history in the table if you need to. So that's what system versioning is really about. You can automatically have the database store the versions of the data instead of doing that logic in the database, in the application, which would be the typical situation currently. And it goes a little bit further than what I demoed. You can use partitioning on it, so that history is placed on different partitions and so on. And then as I showed, you can prune or delete the data as well. One easy way is, of course, if you want to get rid of old data, is to use partitioning and put partitions per year, and then if you want to keep 5 years of data, you always, after five years, you drop the oldest one, the oldest partition. And one very interesting use case also for this is that you don't actually make use of it on the master database. You have it replicated to somewhere, and you store all the versions there instead, because they might be more interesting from an analytical perspective.
How much additional storage would be required when you enable something like this to store all those timestamps per record?
So the question was that how much more storage would you need if you turn on system versioning with all the timestamps and so on. I don't think the timestamps themselves, they don't take that much space, but then of course when you start doubling each row of data, that will of course increase the amount, it's of course hard to say, but if you have big rows of data, then you can multiply by the amount of versions that there is going to be, basically.
Are there any best practices or guidelines in terms of when or how often or how much to use versioning?
I think it's very much a question of what you need to do, actually. So now you have in EU, for example, you have this GDPR regulation where all private information has to be stored in a certain way. You have to be able to tell a person that when was your data updated and so on. So for that, for example, this is very useful. And then it basically has to be on all the time, of course, so that you can get that data. But yeah,
I was going to say, are you guys looking at some let's say, refinements down the road where you could apply some techniques of compression so that basically when I'm versioning data, I'm not necessarily doing a whole copy, of that replica set, but just like having the changes like in a change log. Like,
yeah.
Could you reconstruct this from a change log, so therefore maybe it could, therefore reduce your spatial requirements for versioning.
Yeah, so you're absolutely correct. This is the first time we introduce system versioning, and we do have a roadmap for it. This is MariaDB 10.3, where all this works already. In 10.4, we will introduce something called application time, which is where you can, now the time is always set by the system. There you can have the application actually set the time as well. And after that, there will most likely be improvements like what you mentioned.
Does it only fire on an update, or let's say you have a row, it's the same primary key fired or something. I delete the row and I insert the same row. Will we get a temporal setting on that one? Or
That will be a new row.
that'll be a new row?
Yeah, so it won't be connected to the old one in any way.
Okay.
Yes?
What's the cost of enabling versioning in terms of resources versus like not having any?
So the cost of it is that when you update, you do an additional insert. So that's the cost.
In terms of like storage, is there some efficiency, or is it just like a straight copy of each?
It's a straight copy. So you can actually count the storage needed by looking at your current database and then multiplying with versions and some additional space for the timestamps.
Question is first of all, can you even join two temporal tables, and how efficient would be joining heads off queries with two tables?
Yeah, yes, it's possible. You can use ASOV in complex queries as well, and well, it's pretty much the same as if you would have a timestamp in a normal table, and you would put some criteria on the timestamp. So it's not very bad in any way. But I guess it really depends. Do you want to get one version back, or do you want to get several?
If I'm looking, like, I have a table of instruments and I have a table of their prices, and I want to produce a view of instrument with the latest prices of a month ago.
Oh yes. So then, but
So that's the most common use case for
Okay.
financials.
Yes. So then, in the end, the query towards the system version table will be returning one row. So it will be very efficient.
approach involve creating a virtual fields so that if I can do a select from this table and let's say get 2 records with an additional field, is to add an additional field to the table.
There are these row start and row end timestamps that you saw,
Okay.
but nothing else. No.
Row start would be when it became effective, when it was first inserted,
Yes.
and when it was deactivated.
Yes.
For the replacement of a new record.
Yes. All right. Let's move on a bit then. So Oracle compatibility. This is actually a thing that our customers asked us to create. So we have a big bank, for example, that had a lot of data in their systems, and they wanted to introduce an open source alternative on the database side. And they chose MariaDB. But what they really needed was also some of the syntax that they were using against Oracle. And for that, we have created a few things inside MariaDB. So MariaDB understands sequences now. So you can create sequences. Would someone know what sequences usually are used for, and when they are used?
Primary. Generating primary.
Yes, and yeah, especially when you want to use it in several tables, the same primary key, and you want it to be available before you have inserted the data. So then you would use the sequence. I actually had a demo on this, but I'll skip it for now. If someone wants to see it, I can show it afterwards. But it's pretty much what is said here as well. We can do, for quite complex sequences, we can do circular sequences, for example, so that when you reach a certain number, then it starts from the beginning and so on. Of course, when we were looking at applications that were written originally against Oracle, and this bank with which we developed this together, they had data types and made use of Oracle data types that are not available in MariaDB, or were not, but are now. So these data types are new. We also support the variable declarations in the way they are done in Oracle. You can get the row types, and then we have introduced new control statements that weren't available in MariaDB before. You can use the current value and next value, and you have something called execute immediate for dynamic SQL. So a typical use case, you have an application writing SQL queries, and this is very useful in that case. Some other things that we do on the Oracle side is that we have introduced new cursors that are used in PL/SQL. You can define blocks of SQL code. There are the syntax for procedures, functions, triggers, and packages. So one other area in addition to the storage engines, the Oracle compatibility, and so on, that we introduced in MariaDB 10.3 and in MariaDB TX 3.0 is advanced security. And we were already talking about hiding in invisible columns and so on. So this is maybe taking it even further. So in the product for this kind of data handling is max scale, which sits in front of the databases. So there you can define that, for example, that if someone asks for a column social security number, then we mask the SSN in that data. And of course, partial data masking so that you show something of it, or then you completely obfuscate it.
It's stable obfuscation?
Yes, I believe so. Let me check if that's supported or not, but at least on column. Okay, a few other things in TX 3.0 that we did, and especially if you have used MariaDB before, then you will know that these didn't exist. So there is a quite complete encryption solution available in MariaDB. But one thing was missing, and that was encrypting the temporary files. So that was now done in 10.3. We also added, especially for analytical purposes, the user-defined aggregate functions, so that you get to define your own set of functions. We added a function that was very much requested, which was this continuous percentile. So it's there now. Intersect and except works also now in MariaDB. So with union has been there always, so you can union data from different tables or same tables. But with intersect, here is a good example on how to use intersect. You want to know who is both an employee and a customer, then you would use intersect, for example, instead of having to do a lot of querying from different tables and figuring it out in a procedure or in the application. You can do intersect. Then you can have table value constructors now, so that you don't even need a real table. You just define what should be returned. And some lock timeouts were introduced. So I'm basically covered everything that I wanted. I don't know how much time went into this, but do you have any questions at this point? I'll be here still. There we have a question.
Thank you first for your talk. I have a question according your previous topic when you mentioned instant column creation.
Yeah.
And you said that you can instantly create a column with a default value. Is it right?
Yes.
How is it implemented under the code? Because when you create a column with default value, it means that you should revisit all the rows you have in your table and set this default value if it's not set, but
yeah.
Yeah, that's the question.
Okay, how it's implemented?
Yeah.
If are you curious if it's an update on all rows or?
Yeah, obviously it's not an update on all rows because
Yeah.
it won't be instant
Yes.
in that case. So I think maybe it's storing a default value somewhere, and if it's not set in a row representation of the row,
No.
it is set by default or something like that.
You know what, I would have to ask the developer that question. But I can definitely, if you leave your address, then I can get back to
Yeah,
you.
sure. And another related to the instant column creation question, if we create a column with not null constraint, would it be instant creation or not?
With another column constraint.
Yeah, with not null constraint.
with not null constraint. Okay, so that's a bit the same, I guess, because then you have to go through all the rows. Give me your details and I'll ask the developer to answer you.
Sure.
Yeah, there.
How similar is MyRocks to Level DB? Because I have experience with Level DB, but I never touched MyRocks. And how much has diverged?
So MyRocks is based on RocksDB, and RocksDB was based on LevelDB. And what Facebook, if I understand it correctly, did to LevelDB was to make LevelDB more a server workload database when it had become kind of a embedded thing for Google that was included in things like Chrome. So they wanted it to support their server workload. So I believe there is a ton of changes. Yeah. More questions? We will be here around still for a while. On the screen you now see an offer if you want to come to our conference in February, and it's a pretty good deal. You'll get 50% off if you use that code. So if you're planning to go, or if you're interested, these are good to keep in mind. So the 50% expires in 1 day. So you need to make up your mind pretty quickly. The other one is a little bit longer.
Where is this being held?
This is in the next block there is this hotel. What is the hotel called? The Conrad.
That's
Yeah.
the name of the
Yes.
hotel. Oh, got it.
Yeah.
Okay.
Oh, that's good point. This is 50% off the regular pricing, so it's going to go up even more. So
Yeah.
this is a really good deal.
Any more questions?
All right, so if there are no more questions, we are going to raffle off the prizes. There are a few people still dropping in cards. We're going to do that in a moment. I also want to remind you that I forgot to tell you earlier, we have black vodka for everybody. It's sitting there in the chiller in the back. We were waiting for the endo to distribute it. So what we're going to do is raffle off the prizes right now, and then everyone can go to the back of the room and start enjoying this unique, is it Finnish or Swedish?
Yeah, it's from Finland. I brought it when I came here. So it's directly from Finland. It's quite fresh. It takes only 8 hours to fly from Helsinki to here.
So this unique Finnish delicacy of black vodka. So as soon as that person finishes, has everyone had a chance to put in their cards into this?
It's a black licorice flavor.
Yes. So you probably like it as a Danish.
I'm not real big on black.
Okay.
More a red licorice kind of guy.
Sorry?
Tell us about the black vodka and whites here. Why it's significant.
Oh, okay. So the black vodka thing, why do we have it here? So it started a long time ago. One of the founders of MariaDB and one of the founders of MySQL is called Monty Videnius. So one of these great open source figures still works actively on MariaDB, by the way. So he at some point he started this tradition of that every time he goes to speak somewhere, he wants to serve something that is Finnish to everyone because he's from Finland. And then at some point it turned into being black vodka. And we have continued that. So whenever we come from Finland to speak somewhere, we serve black vodka. Please try it out because it's something pretty special. Yeah, you have to. Okay,
I gotta raffle this thing up
here. So thank you, everyone. It's nice to see you.
Don't go anywhere though, because I am going to raffle that off. But you guys already gave a great big round of applause to Rasmus, so hang on. Once this guy finishes filling out his form there, we're going to raffle it off. We're all waiting on you. All eyes on you.
You'll get the vodka while waiting.
No pressure.
While we're waiting, let's drink. Take your time. Take your time.
All right, guys, he's like 10 seconds from being done, so wait. You do have to be present to win the prizes. Yeah. Drop them in. Thank you, the extra. All right. You guys ready to win some prizes? All right, let's go for the... I know you guys all want vodka, but this will only take a minute, and I'm sure it's worth it. So I'm going to ask you, can you reach in and mix it all up? What should I do first, backpack or to draw the card? Backpack? All right. Can you reach in there, grab out a card, move the other way, grab your own. Read it out.
Mike Wong.
Mike Wong, are you here? All right.
You're welcome.
Can you reach in there and look the other way?
Jivaraj.
Jivaraj Dinaraj. Is that you?
Yeah, so sorry, it's not exactly me. I put up my.
Something a little shady. I think we should pick another.
Yeah, so,
your friend left.
Okay.
Was it you? Wait, hold on a minute. You have to be present to win, though.
no, yeah. So we both have the same card. So it's my friend's card. I pull up and instead of me, it got exchanged. But it's fine. Like, you can, or we can just try it again.
It's not mine. It's your card. It's your prize. You decide.
Yeah. So yeah, I can show you my card.
Do we give it to him? You put in someone else's card. Absolutely. Okay. Congratulations.
Thank you.